Welcome back to the third part of the Superliminal tutorial. In this part we're going to be looking at projecting the actors or any object onto a surface. So to play with that projection trick where if the player stands in the right spot, it will transform a 2D object into a 3D object. So that's what we're going to be doing today, and we're only going to need two different things, so we're going to do those and get into it right away. So first we're going to need is a new actor, which will be a base actor. So create that, and we'll call it a_project. Then we're going to need a new material, which is going to be this projection. So we're just going to call that m_projection. Now I'm just going to get the projection out of the way, so that way it's done and we don't have to come back to it. So I'm going to start by creating that material. So to start things off, we need to change our material from surface to deferred decal, because what we're going to be doing is projecting a few decals onto the surfaces. We want it to be translucent, and that's all as far as the default settings go. So next we're going to make our parameters. So for this we're going to need quite a few. So we're going to start off with, let's say, the location and the directional vectors of our camera, which we're going to transfer into the parameters. So what we need is we're going to press 4. We're going to need, well, 4 of them. One for the location and one for the up vector, one for the forward, and one for the right vector. So we're going to convert all these to parameters. The first we'll call location. The second we're going to call, let's say, right vector. The third we'll call up vector. And the final one we can call, well, the last one, which is forward vector. Now by default I'm going to give them a color, just so that we can tell the difference. So I'm just going to make the location, well, actually no, it doesn't really matter too much, we'll just leave it as is. We're going to be setting them inside of our blueprint later. So we need one last parameter, which is going to be a scalar. So hold S and click, and it's going to be the FOV. Now to keep things more organized and easier to read, I'm going to move these back, and I'm actually going to reroute them. So to do that, drag off and say reroute node. So we're going to turn it into a named reroute, and we're going to call this location. It's just because it's a bit smaller and easier to manipulate after. So we want to do the same thing here, and we'll call this one right. The next one we'll do the same, named reroute, and we'll call it up. Now for the up one we actually need to negate it, so we're going to multiply it by -1. Make sure it's the negative value. And I'm not exactly sure why. I kind of followed not a tutorial, but some documentation on Unreal. I'll probably share it in the description below. So if you want to read through that, which explains more in detail what this is, because I just took the basis that they made and applied it to decals, or at least to my situation more like. So next we want to get the named reroute and call it forward. And the final one is the FOV. So we'll do named reroutes and call it field of view. Okay, so now with that we can get into the actual logic. So the first thing we need is we're going to need the world position. And from the world position we're going to subtract our location. So search for location and it will come up at the top. And we're going to drag this into an inverse transform matrix, which in essence will create a 2D grid that will be projected forwards, if I understood correctly. So for the X, we're going to want the right vector. For the Y, we're going to want the up vector. And for the Z, we're going to want the forward vector. Now, I'm not exactly sure why it's in this order, because it is a bit strange. Now that we're done with this, we can go and add, once again, we need another reference to this, so we can copy paste it. We're going to get the distance. So make sure you get the one here in utility. And for the distance, we want to also once again get location. So with location, we're going to actually turn this into a named reroute as well, because we're going to need to call it again later, which we'll call dist to pixel, which is what it does, it's going to be getting the distance to each individual pixel that we're going to be projecting onto. So then we want to get our field of view here. So call field of view. We're going to multiply it by 0.5. Then we're going to divide it by 360. So pretty much this, in essence, if you think of it in geometry form, we're getting the angle of the camera. Think of it in 2D. We're getting a cone, or a triangle if you want, we're getting the angle of the with the FOV. Then we have to divide it in two, so we get an actual squared rectangle, squared triangle, sorry. And then we have to divide by 360 because that's the well, rotation. And then we're going to use tangent. And so with that, we're going to be calculating pretty much how we're going to get the world space of where we hit for each pixel. So I want to multiply these two together. Once again, if I'm not exactly very clear, it's because I don't exactly understand everything that's going on, at least as far as the material goes. But if you want, you can read the documentation for more information. So then we divide these two. Make sure it's the top one first. Actually going to move this a bit further back because we still need a bit more to add. Next, we want to add 1. So just a simple add, nothing else. Then we want to divide it. So you can also hold D to get it directly. Divide it by 2. And we want to use a component mask to finish, masking out the R and the G. We're then going to promote this once again to a named reroute node, which we'll call projection UV. Now this is the actual system that's going to be used for the UVs here, which we're going to be plugging in a second now. So this is going to be the last touches that we're going to need. So with our projection UV, get that one, we can copy it because we're going to need it twice. We're going to need to plug it into 2 texture samples. So call texture sample, make sure it's plugged into the UV, and we're going to convert this to a parameter. Now the first one is going to be called projected texture, and we're just going to copy this, and we're going to call the second one, because it needs to be different, we'll call it projected mask. Now this is also going to act as a mask at some point, because they're going to be added together right after now. So we're going to get another parameter that we've already made called dist to pixel, and we're going to need to first connect this to the base color, because that's what's going to be useful. They're going to get an error because, once again, they need to have a default material, even if we're not going to use it. So let's just give them a default material. And what we need to do is we need to get our R and say divide, and we're going to actually connect it to the B and divide it by dist to pixel. Okay, so let me just reroute this, it'll be easier to see. There we go. So align that there. Now, once it's divided, we need to floor the value. And to finish this up, we need to saturate it. So just think of this as a way of clamping the value. This is just a more complex way of clamping for the current situation. So let's get that. And so we need to pretty much copy the same thing to our second one. But for the second one, we do need to make one major difference, is we need to do a 1 minus here. So let's just move everything back again, because we still need a bit more space here. Just make things easy to read. So let's just unselect that and move it away. So now we need to multiply these two together. And once we have the multiplier, we can attach that to the opacity, because it's going to be what we see, or at least what we want to show. And just to make things look nicer as far as the texture goes, we can add a 1 vector here, or just a float, and attach it to the metallic and specular. And make sure you leave it at 0, because that just means it'll act as an unlit material, but without changing it here, because if we change it here, sorry, we don't have access to it, and even if we did, we would lose most of the functionality here. So maybe like that. So we're done with the material now. We don't need to touch it anymore. Just maybe keep it open so that we make sure that we use the correct values once we apply them. So next up is, well, we're going to need a, let me just double check something. Okay. So next we're going to need our our new actor. So let's go and open that. And with our new actor in hand, we can start, well, finishing up, let's say, even though it's going to be a bit of a while before we're finished. So we're going to add a scene component 2D because that's the most important part of taking a photo. And for the values, we're going to leave it by default here, nothing changes, but we're going to need to make a few changes here. So the first one we want to do is we want to change our render scene to use show only. This way we can take a photo of one actor and one actor only by telling it which actor that is. We also want to capture every frame off and capture all movement off because we only want to take a photo. We don't want to take a continuous capture. We need to make sure we always persist rendering state because otherwise it will show a warning, which can get annoying eventually, so we just remove that for now. We can compile, so now our scene capture should be done. I'm just going to double check. Oh wait, no. One last thing we do need to add as well. Inside of the general show flags, we want to disable the atmosphere and disable the clouds because otherwise the photo, even if we say show only, for instance, our cube that we want to take in photo, it will still take a photo of the skybox and all that, and we don't want that. We just want to have our cube, so we have to disable these two here. So make sure that's the case. Now once that's done, we're finished with our scene capture, and we can move on to, well, getting our different variables and our functions. So we'll start with the variables. First we want to call our projection target. So that's going to be the actor we want to take in photo. So it's just simply going to be an actor because we don't actually have to limit it to anything because it's a photo. Then we want to do projection, or what do we want to project onto? So project on. And for that we do once again an actor, and we'll say it's an array. Okay, so with that, make sure both of them are both exposed because we're going to be setting them once we place the actor. Next, we want to make a few functions. So first, I'm just going to create them all, and then we're going to go through them individually. So first, we want something that's just the base, which will be the project item, which is going to actually do the whole logic. Next, we want one which is going to be sort by distance, because we need to make sure that when we project onto something, that the objects we're projecting onto, so this array right here, is in the order of closest to furthest, because otherwise we'll be mixing up, let's say, the masks, and we'll end up with something that looks a bit weird. Next, we're going to make a custom trace, which we'll call trace for projection. And then we want to, well, because we're using multiple boxes, we're going to make box trace info. That way we don't have to do it multiple times. We're going to need something to update material values, which we're going to be using to change, well, our projection material. Finally, we're going to want is player in position, which is going to be for once we finish this and we want the cube to be visible again. Then we want to call free actor, which, if this is true, will free the actor from its current situation. So let's start with our project item. We'll make our way through project item and then we will apply it. So the first thing we want to do in project item actually is something that's rather important, even though you might not think so, is we need to make sure that, for instance, let's just add one here. I'm going to add a cube, so this will be what we'll project. And we'll add a projection here. One thing we need to make sure we do is that the camera is actually always facing directly the cube. Because although you could take a snapshot like this and it would work, for instance, it would project it somewhat there, that would work, but the player wouldn't intuitively know to look this way to get that result. So you can leave it like that, but I think it's better to just immediately make the camera face the cube. So that's what we're going to do here. We're going to, actually one thing first, if I'm correct. Yeah, so what we're going to do also, we're going to make sure this is cool in editor. So then we can actually test it here and see the projection beforehand. So what we want to do is we're going to first tell it to get our capture component. We're going to get our projection target, and we're going to get world location for our capture component. We're going to get actor location for our target. And we're actually going to find look at rotation. And with the look at rotation, we're going to set our rotation here. So set world rotation. And with this, now our actor will automatically look at the target. So we won't have to bother with, for instance, making sure that it's perfectly aligned. If we press project, oh, sorry, that won't work because we haven't actually given it anything. So we select our A movable and project, it will look at it. Now we can put this in construct script as well, and it will do it when we move it. And here we'll automatically look at that. It does the same for height. So as you can see, now it aligns as it should, which is the goal. So next we're going to tell it, our scene capture, which target it's looking for. So we're going to get show only actors. And this pretty much, just think of it as what we're trying to take a photo of. So we're going to add, and we're going to add our projection target. So with that attached, this is done. So next is a sequence, and we're going to go through 3 different points. So the first one we're going to need is we're going to create a render target. So this is something that I didn't know existed before now, is the fact that you can actually manually create render, or automatically create render targets inside of blueprints. So this helps a lot so that we can actually make as many of these as we want. We don't have to bother with creating our render targets like this as before. So we're going to make it higher quality, because otherwise we won't actually see something nice or see pixels. And we're going to get our scene capture and say set texture target. And it's going to attach there. And the next thing we want to do is we're going to, well, capture a photo. So capture scene, call that here. And we're done. So with that, we've taken our photo. Next up is we need to make sure that everything is sorted before we go taking the extractor. So think of this as we've taken a photo of what we want to show. Now we're going to reorder our different project onto actors, and then we're going to actually project onto them. So we need to call sort by distance here, and we're going to make that function. So sort by distance is something you've probably done multiple times. We're going to get all our actors, so get project on actors, and we're going to call last index. Then we're going to go through a double for loop, which will get us the information that we need. Not a break, just a simple for loop will do. And we're going to put this on last index. We're going to promote this to a local variable, which we'll call L index A. And we're going to use, well, index A to also here get our project on, which will say get a copy. And we'll promote this to a variable as well, which we'll call L, let's say actor A. Sorry, remove the brackets there. And now we're going to do pretty much the exact same thing, but we're going to do it with a second one. So copy and paste, but instead of using index 0, we're going to get index A, because we're looking for actors after it. There's nothing we need to look at before, because we're sorting. So next we want to promote this again, so we can actually copy this, and we're going to attach it here. And what we'll do is we'll just duplicate this, call it B, duplicate the other one and call it also, sorry, actor underscore B. Now we just want to right click on this, replace variable with index B, and replace with actor B. And to finish this off, all we need to do is we're going to make a branch here, and for the branch we're going to check distance. So what we want is we'll get projected, so we'll get A and B, and we want to use B at the top. We'll say get distance to. Make sure you detach it and put it on other actor. Then we will do the same thing at the bottom, and we want to make sure if B is inferior to A, so if this is the case, make sure you get it the same. Then we want to swap. So that's pretty simple. We're just going to get a reference to project on. we're going to say swap array elements, and we're going to get index A and index B. So align these, and on true we swap. So with that, we're finished for our sort by distance. So we can go back to our project item, and next up is we're going to call trace for projection. So this is for the mask. It may not be very intuitive as far as the name goes, but that's what it's called. So what we're going to do here is we're going to call a multi box trace by channel, and this is where we're actually going to use our box trace info. So you know what, we'll actually get rid of it and we'll make it here, and then we'll copy it. So we're going to start at actor location. We're going to apply that to start. We're going to add our scene capture 2D get forward. We're going to multiply that. In my case, I'm going to use 5,000. Obviously, if you want to change that, that's fine. 5,000 is just a very long distance. So it's just to make sure that what we're going to do is just at a correct VAD distance. Now we're going to actually reroute here, and we're going to get world rotation, and we're going to apply that here. Now we can collapse this to a function, which we'll call box trace info. Make sure it's a pure, we don't need anything else. And we're going to go into it and actually set up this to be 200 by 200 by 200. So this is going to be, it's a very big projection. We want to make sure that we hit everything that we could possibly hit here. So back in trace project, so the main thing, we want to do a for each loop. And we want to call from our out hit array. We want to, actually first, one thing we want to do, make sure on the axis to ignore, we want to call project on. So the reason is because with this cube, we're trying to tell it which axis to ignore in the next trace we're going to do, because we need to do it twice. So we're going to break our hit, and we're simply going to say, actually, we're going to create first a local variable, which is going to be an array of actors. So we'll call L ignore. We're going to need a few other ones, but for now, we'll just do that one. So get a reference to it and say add unique. Attach it to the lower body and the loop body, sorry. And there we go. So we're finished with our first loop. Now we can reroute here. I'm going to do our second one. So for the second one, we're actually going to start off with a for each loop, because we're going to go through individually our items we need to project on. So let's go here, and there we go. So we're going to promote this to a variable, which we're going to call L current target. Now with L current target, it's just to more easily get it instead of doing massive reroutes, because it's going to be quite long. So here we're going to call a simple box trace by channel, not a multi, just a box trace. And we're once again going to need our box trace info, which we're going to attach like this. You can rename these, we'll leave them at that for now. No point in changing them, they're only used here. Now here, instead of using our project on, we want to use our ignore list. And with that, we're going to, now normally remember, due to the fact that we've sorted this by distance, we're always going to hit the first actor. We're always going to hit the initial target because we're going from closest to furthest. So that means we don't actually have to add our other projects on to the ignore because they're actually behind it and we're only going to hit the first target anyway. So, but we're going to add them later so that the next in the line ignore the previous ones. So we're going to need a sequence here. And for the sequence, we'll just do the end first, so you don't forget it. We're going to get a local, we're going to create another local one we'll call L show only. And this is going to be add, and we're going, I didn't mean to delete that. We're going to add our current target to this. So we have that, and then we also need to add, well, as I said before, our L ignore, we're going to add our current target. So that way that the next one isn't bothered by the one in front of it. So Now we're actually going to need to do the important stuff, let's say. So we're going to get this and break. And what we're going to do with this information is we're going to need a hit component. We're going to cast our hit component to a static mesh component. Sorry, cast to static mesh component. Put it on then. Then we're going to need our trace end minus our trace start minus trace end, sorry. And we can now close that, or minimize it at least, because this is all we need. And we're going to normalize this. Okay. Now, the next part, we're actually going to do a bit of, let's say, math, because we need to, when applying a decal, as if you've ever tried applying a decal, you've probably noticed that the decal applies on any surface that the size of the decal touches. So we're going to do a bit of math, it's pretty simple, to project it, but only on the sides that we need it to. Now, originally I tried projecting it just on the front side, and there's actually some calculation you can do in the material to do that, but that doesn't work because when you project the material from 3D to 2D, it actually needs to stretch on the sides of objects sometimes. So we just want to make sure it doesn't appear on the back. So to do that, we actually need to, usually what I do is say get component bounds. But the problem with get component bounds is that it isn't rotated to the world. So if the actor is rotated 45 degrees, it doesn't know what to do, and it will have a massive bound, which is incorrect. And we need it to be attached to what we want. We need to be specifically adapted to the orientation. So to do that, we're going to do a bit of calculation, and we're going to use the local bounds. Now, local bounds act pretty much as, let's say, minimum is bottom left, maximum is top right. So it kind of puts in the corners, and we use that to calculate the rest. Now, one thing worth noting, and I don't know why this is, but even doing this method that I'm going to show you now, it doesn't seem to work for some actors. So what I mean by that is, for some reason, our plane here, for instance, it doesn't seem to work, and I believe the reason is because of the pivot point. If the pivot point isn't centered, it doesn't really seem to like that. So that's why I suggest when projecting to use stuff with a centered pivot point like this, for instance. If it is indeed centered. I think it is. Yeah. So this should do. So we'll test it and we'll see. But normally it doesn't seem to work with strange pivot points, which I don't understand. So, but if you want something more like final for like an actual project, an actual game that you want to sell, maybe look into this into more detail. I'm sure you can find a solution. So what we need to do is we're going to need a few reroutes because this needs a few variables. First, we want to get owner because we need to get its world transform. So we're going to get actor transform here. So because this is in local space, we need to transform location. Location, here we go. And so for that, we need to say minimum there. And for maximum, we'll do the same thing. Now with these, we can add them together and we can then divide by 2, and that will give us our origin. So just do that. I'll just note here origin for now. So this is where we're going to place our decal. So next we want to get is our actual box extent. So we want to get world scale, and we need to multiply this by our world scale, sorry. So this will then be here, and we'll call it world scale. Sorry, box extent. And finally, we also need to get the world rotation, which is just simple, get world rotation. So we can collapse this, but for now we'll just leave it as that. So what we need to do is from here, from the valid, we'll drag out and say add decal component. So with that, we're going to make sure everything's right. So we can split the relative, and we need to make sure that we tell it is manual. So when we say it's manual, it means it's world. So we're going to add out. So actually, before we just do this with the origin, we need to make a little change here. So we're going to need our normalize here, which is pretty much, think of it, the direction we're looking for, we shot from. So how we want to offset our origins so that the back doesn't have any decal on it. So to do that, we're going to multiply this normal vector, and this is kind of what I found, but I put 5 here, 5.1. And then we add plus, and we're going to add that to our origin. So we apply that to the transform. For the rotation, we're simply going to get our world rotation from here. And for the box extent, we actually need to do, again, we're going to call a plus here, and we're going to add 5. So the reason is we want it to be just 5 units bigger on the extent, and we want it to be moved 5.1 forwards. So that you need to make sure that this value here is smaller than this value here. Otherwise, you'll have the decal appearing on the back of objects. So we can promote this to a variable, which we'll call local LDecal. And we need to actually, before I go any forwards, we need to make sure that the decal size is set to 1, 1, and 1. So the reason we're doing this is that this here is the actual size. So we're going to set world scale 3D. And with set world scale 3D, we're going to apply that. Now, the reason is because there's no way to say set decal size. We can set its fade screen, but that's not what we want. So now that we've done that, we have our decal. So our decal now exists, and we now need to set its material. So to set the material of the decal, first we need to create another render target. So make sure you select the create render target 2D, not the canvas. And for this, we can make it 124 by 124. Now, obviously, if you want it more precise, you can do that, but I think this might even still be overkill. Feel free to fiddle with it if you want, or just use that for now. So we need to reroute this, and we're going to get a reference to our scene component 2D, and we're going to get its relative transform, the transform, and we're going to, well, create another scene capture. Sorry, add scene capture 2D. Just like with the other one, we're going to need to make a few changes. So attach relative here, and make sure that we once again disconnect these two and set this one to show only. But make sure here, instead of using scene color, we want to use scene depth in R, so in red. So now that that's done, once again, we need to make sure that our atmosphere doesn't show and our clouds don't show. So the main one is the atmosphere, to be fair. The clouds are not too important, and remove both is better, just to be sure. So now we're going to get this one here. So this, remember, is our render target. And we're going to say set texture target here. And for the set texture target, well, we're going to put the one we created. So here we're going to need this a few more times, so I'll add a few reroutes as well. Let's just move this down. Another one here. And we're going to need to set our show only arrays. So get it. And we're going to append our show only. So let's put that there. And finally, one last thing. We reroute here and we say capture scene. So with our scene captured, we now have a mask. So now that our mask is ready, we need to continue this reroute. Oh, not that, sorry. We need to reroute. So with this, the final part is we need to create our material. So we're going to create a dynamic material instance, which we're going to make based on our n_projection. Sorry, I mistyped that. Projection. So let's get that here, attach it, and what we need to do is we're going to reroute it, and we're going to start off by, well, getting our decal and say set material. And it's going to be, well, our decal material that we just created. So next we need to apply our parameters. Now to do that, we're going to use our function. So it's gonna be this one, but I'm actually gonna recreate it here because it's gonna be easier. So let's reroute that and reroute this. And we're going to collapse this to a function, which we'll call update material values, or parameters maybe is better. So let's just inverse these two, So it's easy to put here. Go. Okay, and one last time. There we go. So for just to make sure, this is the material and this is the texture target. So let's go inside of there and let's finish this last bit up. So we can remove the reroutes. We won't be needing them too much. So first thing we want to do is we're going to add our world location and stuff like that. So we want to get world location. And for get world location, we need to, so we're going to get our material. And for the get material, we're going to call set vector parameter value. And we're going to use this 4 times. So we're going to copy it 2, 3, and 4. So for each of these, we're going to need first the world location. So when we attach it, it will convert it to a color, which is fine. That's what we want. So first, we want the location. So let's call our names, just to make sure we'll call, just copy paste it to be sure, location. Then we're going to get our right vector first, if I remember correctly. It doesn't really matter, obviously, the order, but just to keep things in the same logic. So let's double check. We have our right vector. So let's copy and paste that. Then, once again, get our 2D component. We're going to get up vector. Attach that as well. And it's probably going to be the same, so I'm just going to copy this and replace right with up vector. Apply that, just make sure it's written the same way, of course. Line, and let's just tidy that up a bit more space. Go, and the final one is going to be our forward vector. So let's just go and forward vector. So get scene components and forward vector. So with that, there we go. And now all we need to do is we need to add our FOV and our parameter and our actual textures. So with our material again, we're going to say set scalar parameter value, which was FOV. Double check. Yep, FOV. And we're going to get our field of view. So get field of view. Now, because we didn't change the field of view here, we don't need to change the field of view in all the ones we create as well. So just make sure that they're all the same, otherwise it might not work. You'll have a few disparities between the mask and the actual material itself. So next we want to add our materials. So we'll call set texture parameter value. And the values we gave it was projected texture. So for projected texture, we're simply going to call our scene capture. We're going to say get texture target. And we'll do the same, and unlike this one, which we've saved here, for the one here, which we can copy, because we simply need to change the texture to mask, we need to simply call our variable or parameter, which is just simply calling texture target get, and it'll be at the bottom in the variables. So we can attach this, and normally our material is set up. So let's give it a go. Let's just save this. Let's let it compile. And once it's done, we can test it on our environment. So let's just make sure, for instance, from this angle, it'd be about correct. So we need to make sure that we have our projection target, so our cube, but we also need to tell it to select where to project it on. So let's project, and it appears. That's not looking like much here because, well, it's just a cube, so, and it's not exactly the best angle, but it has a bit of trouble with the lighting, so you might see a bit of a pop when you actually stand in front of it and change it back. So let's, to make sure it works, right, let's copy this, and we're going to rotate it slightly. We'll make it a bit smaller. No, sorry. I don't know how it deals with actually negative values, so we'll try not to do that. Let's add a second one, which will make more of a pillar. So like that. And we'll add another camera here. Oh, sorry, another camera. So if you move it, obviously it's going to remove the projection. Remember that. So we'll just copy you. And what we'll do instead of the current material, we'll put a checker material. So that material right there. And it looks a bit weird because the UVs are unwrapped like that, so we can't do much about it. We're going to select that. We're going to select this, and then we're going to select the one behind it. So let's try and align it as best we can so that it doesn't look too weird. And now we can project, and it indeed aligned it. And as you can see, normally there's nothing behind, because if we select our camera again, we can see how the decals applied. So they apply right at the limit before it starts blinking, because if it has the same value, it will start flickering, which you don't want. And it appears on in front. So this may look weird here, but normally if we align ourselves exactly with the camera, it starts to line up. So we're a bit behind here, so that's why it doesn't look right. But it's a bit awkward, right, to get into the correct view. So it does work. Even if these are rotated at 50 degrees, it still works, there's no problem. So next we just need to make it so that the player can actually start it, get it to work. So one thing you do need to be careful with is you need to make sure that this is at the right height for the player camera, because otherwise it will be a bit awkward. You won't be able to actually see the image correctly because it's not the right height. So make sure that that's set up correctly. I think 162 is usually where it's at. So we'll try with that and see what happens. So now we're going to do our last two functions. So first, we're going to go to the event graph. We're going to need two things. We need the tick and we need the begin play. So for the begin play, if I run it right now, the projection doesn't appear because it doesn't actually take the photo. We actually only run it in the editor. So we're going to call that here on begin play. And another thing we need to actually do before that is, as you saw, it falls. We don't want the cube to fall. That's not the goal. We want it to stay there. So to do that, first, what we'll tell it is we're going to get our projection target. We're going to say set actor hidden in game. So like that. And we're going to tell it to be hidden. And we're also going to tell it to enable to disable its collisions, so that if the player runs into this cube while it's hidden, then that's not correct. It's not there. It shouldn't exist. So we don't want to show that. So with that, our cube will disappear, but the problem is it's still going to fall. So we need to make a small change here. So we're going to open our A movable, and we're going to tell it on begin play that if it is locked, so branch here, if it is locked, so let me just double check so I want to be sure I do this right, even though it's pretty simple. If it is locked, we simply want to tell it to simulate physics to false, so that it doesn't actually fall. So we can now close our A movable and head back to here. So the last thing we need is a branch, and we're going to need our free actor at the end. Now you could do this with a timeline and, for instance, a collision that detects the player is close, but for simple sakes, to keep the video as short as possible, we'll do it on the event tick. So we're going to need our is player in position, and we're going to add a return value here, and we're going to convert it to pure. So what we're going to check for the player is we're going to check if it's, now this is why I made it so the camera looks at the cube every time. We're going to get our rotation and location, so get world location, and we're going to then get world, and then we're going to get camera manager. So if you got the player here, as in the player character, it won't work because the player character location is in the middle, whereas we're trying to get specifically the camera. So either you get player character and get the camera from it, or you can just directly call get player camera manager. So here we're going to say get actor location, and we're going to say if these two are double equal, and I put 5 here, you can feel free to change that as you want. We want an and node because we also want to check for the rotation. So from here, we want to get world rotation, and from our camera, we will get actor rotation. And if these two are just like the other one, double equal, this time we'll put 2 instead. If these two are double equal, then we're in the right position and we can re-enable the cube. So to do that, we'll say go into free actor. And for free actor, it's pretty simple. We'll just do the opposite of what we did in the events in play. So we'll copy that and we will hidden no and enable the collisions. And with that, we then want to check if it is a movable. So we'll cast to a movable. And if it isn't, we're simply going to, well, destroy this actor, because it doesn't need to exist after the puzzle's been solved. But if it has, we want to is locked. We want to set that to false. And we want to get our static mesh and tell it to simulate physics again. True. And after that, we can once again destroy our actor. Make sure it's destroy self and not the actual cube. That's not the point. We're just trying to destroy the actor. So normally now, if we go into the game and play, and we align correctly with the cube, it should... Okay, so it did work. It did realize we're in the right location, but something went wrong. The cube should have reappeared. Did I maybe put that incorrectly? Okay, I'm just going to double check that when we play, it is still there. So let me just pause that. So where is your static mesh? Aha, so the simulate physics is not actually being called correctly. It's still falling. That's not what we want. It's because I forgot to put is locked. So that's stupid of me. So let's go again, and let's try and see if it pops into existence. So we're almost there. Let's try and get as close as we can. So as you can see, it's very precise, so I need to actually be in the perfect spot. So I'm going to, for instance, look at our project 2 and see where it is. So I'm not actually looking at it correctly, apparently. So how did I manage to get it on the first time, but I can't get it now? Just want to double check where it is. Okay. So what we'll do is I'll just make it so that the player is in front, pretty much, and I can just easily make just a walk forwards. So let's just do that. And normally, if everything works correctly, I should be... There we go. So the cube does appear. We can pick it up just like normal. Place it again. And if normally we do the... should be able to do the same thing here. Now something went wrong there. For some reason it projected and removed the corner. That's strange. So that might be caused by the fact that our mask is... so sometimes that can happen, and I'm not exactly sure why it's sometimes and not all the time, because it will also happen here because of the color. So because of this, we're also using it as a mask. It will consider sometimes that the color is correct. So what we could do, I'm not sure if this will work, but you would have to replace, for instance, this, remove it and take another capture of the mask. But you can't inverse it because this is the actual cube itself. So it's a bit difficult to explain, but normally it does work. Don't know why it didn't just decided to not function when we begin play. Because here, oh, see, so here we have the problem as well. So I'm not sure why that is. Okay, so I'm just recording this a bit later. So I went ahead and tested on my own project how to make it so that we could have an extra projection, just to make sure that we don't have that weird corner bug here. So let's just show that again. So just so that we don't have this bug here. So I'm just going to set that up now and show you how to do that. So we're going to need our project, and we're going to need our material again. So in the material, we're going to actually detach that, and we're going to move it because we just need to connect this here now. We're only going to use it as a material. We're going to copy this, and we're going to rename it, the new one, to, let's say, actor mask. So that's the name we're going to give it. We're going to get the R and apply it there. And so with this now, our new mask will be just like the other one. It won't have any issues. It will be all red, so it won't be a problem. So in project, we're going to go close these. We're going to first update our materials. So get the material. So get, we're going to set texture parameter value. And just like before, we're going to paste that here. Now for the value, we're going to duplicate our scene capture component, and we're going to call it mask. because we duplicated most of it will stay the same. We just want to change our scene color to scene depth in R. And we're going to get this here, get our texture target, and we're going to apply that to the material. So now before it's done, we actually need to set up the information for it. So inside of the project item, first we need to set the rotation. So grab our mask here and apply it there. Next, we need to do the same thing that we did here, but for the mask one. So let's just copy that and paste it here. So there we go. And we're just going to replace this by mask. And finally, we need to create a new render target. So we're just going to put it on number 1. So move that a bit. We can just copy paste this mainly because there's only the actual variable here to change. So connect to mask. Connect the mask here. No, not like that. We want it to be a replacement. There we go. And we can make this a bit smaller. We don't need it to be that high quality. 1024 will do. And with that, we should be done if we take another photo. So currently, the reason you have 2 is because they're not aligned. If we do that, it should work. And if we play, we no longer have the weird glitch on the right side because of the dark. And the same here, it's just darker as it should be. So with that, we have finished. So I hope you enjoyed the video. And as you can see, it works perfectly. I hope you enjoyed, and I will see you in the next tutorial or next video. Goodbye.